So we're going to move on today to 4.4, the short way of finding the area under a curve. Yesterday...
Tonight.
Okay.
We already told her that when you left.
The authorities, what's going on?
Okay, so yesterday were some basic geometric shapes, so now we're not going to do basic geometric shapes anymore, so we need a way to do this. So we have the integral from A to B. A is always smaller than B. So if you switch it, you have to put the negative out in front.
Yeah.
Remember that? F of x, let's say it all again. The integral of A to B of f of x dx, you do, once you find the integral, you plug in B and subtract what you would get when you plugged in A. That's what I was doing yesterday when I was doing it quick.
She didn't cheat on me. He cheated.
Okay, Natalie, do your homework tonight.
Like she can do it, but she wants to think she can.
Excuse you.
Are you ready? No, Kayla's not.
I didn't write the words this time.
You don't need the words.
Well, yesterday you were attacking me, so I didn't today.
Listen, Nick, we're waiting on you.
I was waiting on you. Okay, so the guidelines for using the fundamental theorem calculus. I did the algebra the other day in another class. Provided you can find an antiderivative, that means it is continuous and differentiable over the period, the interval, so you can find the antiderivative. You now have a way to evaluate the definite integral without having to use the limit of a sum. That was what we did for the last 2 days, and it was long and horrible. So you apply the fundamental theorem of calculus. The way we do it is we find the antiderivative, and you can put this bracket. I tend to just put a straight line. You'll see more places put this just a straight line rather than a bracket, either one. And then you carry over your B and your A. So you plug B into the antiderivative and subtract what you get from plugging A into the antiderivative. When you do that, you'll have the area. So the example they have is the integral from 1 to 3 of x cubed dx. So the integral of x cubed would be x to the 4th over 4. Correct? Add 1, divide by it. So then you plug in 3. So you have 3 to the 4th over 4 minus, and you plug in 1 to the 4th over 4. So 81 minus 1 is 80 divided by 4 is 20.
I think it's 20.
Now, the last thing just says it is not necessary to plug in the constant any longer because of the fact is if you plugged in the constant, in the first one you would have plus C, and in the second one, after you distributed your negative, you would have what? Minus C, so the C's would reduce out. So it's not necessary to put the C's in there. But don't forget, if you're finding just the integral, you have to put the plus C. So it's one of those things that people tend to forget when they have to go back.
But that's only if there's a constant.
Well, there is a constant here. It just you're adding it and subtracting it so it zeroes out. So
That's just...
it would be the same constant that you're adding and subtracting, so it just zeros.
Nelly, right? Aye.
One.
Let's do it.
Are you guys good?
Yeah.
It's ready.
This is my how do you write your eyes?
How do I write my eyes?
Yeah. Yeah, the dot comes last.
You're all wrong.
You do the dot first.
Because then it's just going to be perfectly in line.
It's perfectly in line
No,
there.
But it's not like the more you write.
It is easier to put a dot in place than a whole eye.
No, but you just like It's just one continuous motion. It's just you lift up your pencil. Versus you have to.
That's not continuous if you lift up your pencil.
That's
It's
just
one
continuous.
continuous
think it's just-
swipe still.
No, you still cannot. No, that is not continuous.
Scales are different.
Okay, anyway, let's focus. Okay, evaluate each of the definite integrals. The integral from 1 to 2 of x squared minus 3 dx. So the first thing I need to do is what? Find the antiderivative. So you find it, I'll find it. We better get the same thing.
The what?
How do you find that?
Remember, you add 1, divide by it.
Yeah.
Find the derivative, you subtract 1, multiply it by it.
Why are the limits where they are?
Because after you perform, I just performed the integral.
No, up top. Like,
Oh,
where are they
I don't know.
above it?
That's how it's typeset. It's like the summation. I can't get it to put above and below it. It puts it next to it. It's just the typeset.
I feel like it's been normal most of the time.
So wait, what did you do to get the thing that you just did?
You add 1 to the power and divide by it. So 2 plus 1 is 3, so it's 1/3. Okay, so do we have the integral?
Mm-hmm.
So now we plug in b. So I have 2 cubed is 8, so I have 8/3 minus 6. Okay, that's plugging in the 2. I don't normally put parentheses, but I'm just showing you. Minus, do you have to put the parentheses on the next one, though?
Yes.
Yes, because you have to do what with your negative?
Distribute.
Distribute. So then I get 1/3 minus 3.
Yeah.
So I have 8/3 minus 6. Actually, how about 18/3, right?
How about it?
18/3 minus 1/3 plus 9/3. So negative 19, negative 10, negative 2/3.
Mm-hmm.
So we liking that better?
No.
Oh no, I didn't mind the other way.
I did.
You didn't mind the other one?
Like,
It took forever.
Got into it, it was just kind of.
Well, yeah, but
easy.
it took
Everything
forever.
just worked out.
It was very easy for me.
Okay, so now we have 3x to the, well, I would only write it on my paper 3x to the 1/2. Anybody else?
I copied that.
Okay,
Although
well,
I probably wouldn't normally, but I just wasn't paying attention.
so can we put the 3 out front if we want?
I guess.
Yeah. So x to the 1/2 dx. So plus 1 would be 3/2. Divide by 3/2 would be 2/3. So 3 times 2/3 x to the 3/2. So how about 2x to the 3/2? And we have 1, 2, 4. Okay. Now we need to plug in 4. I'm probably going to not plug in 4. I'm going to plug in 2 squared. Why do you think I'd plug in 2 squared?
Because you're going to get rid of the denominator.
Right, because I have 3/2 and I could reduce out the denominator. So I have 2 times 2 to the 2 squared, sorry, to the 3/2 minus 2 times 1 to the 3/2. So that gives me 2 cubed, which is 8. So 16 minus 2. So 14.
Yep.
Now, this 2 where I have it, remember I kicked it out here? I could have just done this.
And you would've got 7 in the old parentheses.
And I would have got 7 and multiplied that by 2. So with 2s, I probably will stick it in there. But if it's bigger, I would probably leave it out. You'll decide how you want to do it. There's nothing that says you have to do it one way or the other. Questions?
Are we done?
No?
Oh.
Well, yes, but there's other. I think we only have one more example.
Well,
If I look at your assignment. Let me make sure I give you enough information.
No, we don't need that. We good.
Oh, no, we have to do a few more.
You.
Okay. Ooh, look at that.
I don't like it. Take it back.
So I have the integral from 0 to pi over 4 of secant squared x dx. This doesn't have parentheses around that x and it bothers me. So if you look at your derivative sheet, what has the derivative of secant squared?
Tangent.
Mm-hmm.
I don't even have a derivative sheet.
I was going to say, it's kind of a secant goes with tangent, right? So we get tangent of x from 0 to pi over 4. So the tangent at pi over 4 is 1 minus the tangent at 0.
Um, 0.
Mm-hmm. So the area is
1.
1.
I didn't think you were making 1 there.
Okay, so what we have now is an absolute value. Yes?
Yeah.
We might have a problem with the absolute value. So what you should do is you need to see what it looks like. You can put it in your calculator or you can sketch it. So if I plug in 0 to this, 0 times 2 is 0. Minus 1 is negative 1, but the absolute value is 1. So I'm here. If I plug in 2, I get 4 minus 1 is 3. So 1, 2, 3. But somewhere in the middle of there, I have a what? And I have a 0. Actually, I put it the wrong place. And
That'd be.
it'd be at 1/2, wouldn't it? Because if I set this equal to 0.
Yeah.
Okay, so at 1/2, so I have this, and I have what? That. So this is where I use my break, and I go from 0 to 1/2. This has to be negative on this one, though, from 0 to 1/2, because my slope here is what? Negative. So it's negative, and we're going to have 2x minus 1 dx plus what to what?
1/2
To 2
2x minus 1.
of 2x minus 1 dx. So do you guys want to distribute this? Just make it negative 2x plus 1? Okay, so negative 2x plus 1. Okay, so that integral would be what? Add 1, divide by 2, so negative x squared. Plus x from 0 to 1/2. plus, well, that would just be 1/2, or x squared, sorry. So x squared minus x from 1/2 to 2. Natalie, am I losing you?
In slowness? Yes.
I'm going too fast?
Um,
Or what?
I caught it.
But am I losing you understanding wise?
We just did the thingies, didn't you?
Yeah.
And then just,
Did you understand why this was negative?
what was named?
The first one, why it was negative?
Um,
My picture is kind of crappy. I've drawn on it several times.
you made it negative?
Well, yes, I made it negative, but do you understand why I made it negative?
No.
Okay, so here, what is my slope?
We have 1/1.
No, like this line is negative.
Yeah.
So that triangle, we need to have a negative out in front of it.
Oh.
And you're here.
Hey.
Okay. Because that has that negative slope, we gotta change the slope. Okay, so then, let's see. 1/2 squared would be 1/4. So negative 1/4 plus, can I just put 2/4? Did I lose anybody if I do 2/4?
No.
And I'm just gonna write minus 0. I'm not even gonna plug 0 into both. Because when you plug 0 into both, you get what?
I think 0.
0. Kayla, are you even paying attention? Okay. And then
All of that work.
it's plus, so I don't need to worry about parentheses. So 2 squared is 4, so that's going to be 16/4.
Mhm.
And then minus 2, so 8/4. Plus, nope, not plus.
Minus.
Minus.
Or just negative and the second is positive.
1/4. And minus 2/4. So I distribute the negative and makes that positive. So I've got to go down the line. So I have 1/4, 17/4, 9/4, 8/4, 10/4.
Or 5 halves.
Or 5/2. Do you guys get the same thing?
Oh, I didn't do that. I was just talking.
You got 12.
What would I do it again?
So 1 and 2 is positive 1.
Yes. And then you have
17,
minus 8 is 11.
9. 17 minus 8 is
that's where I
9.
got off. That's where I got off.
8, 10.
Yeah, that's where I got off.
Okay. Well, I got the same thing the book
You really
did, so.
convinced me it was 11. I was also trying to think, wait, that can't be 9. Oh no.
I don't know why that. It's my brain being dyslexic. I'm on math.
What happened on the floor right
Okay. Now the book decides to, like in the middle of the section, say, oh, now find the area under the curve. Guys, you've been finding the area under the curve the entire time.
That's what this is.
Yes.
there? Why would you do a picture
I
of
thought
this
this was
one?
calculus.
It is calculus.
Well, this is the fundamental theory of calculus, yes.
Okay, so you can check these in your calculator, and I think I've shown you this before. Under math. You don't think so? Take out your calculator. See if you find it. Okay.
So is this just how we cheat now?
Well, you got to show me work.
The best way to
Calculator?
cheat by just having the full PDF of the book already.
That is fair.
Yeah, it's not like you haven't had all the answers the whole day.
I always forget that I have.
Okay, so under math, do you see derivative?
So I have to find that.
I see derivative right there.
Do you see integral?
I see integral right there.
So we have, this one is finite
And
integral. So you push it,
But that was
I already clicked it.
okay? And do the absolute value one. So put 0, 2, and the absolute value, you have to go back to math and number, and you'll see ABS.
Times,
Oops, what did I do?
and it'll appear as lines on these vectors in
Then
parentheses
it-
with
then it
ABS
becomes
on the
2x.
-1.
2x minus 1.
I love it how it like asks you to put in an X, but there's only one variable on the calculator. Like, there's no choice. I mean, I guess the button says XT alpha.
theta and xt theta and
I don't get what you guys are talking about. This calculator talk, I don't get it.
Do you have
You
this?
could say
Yeah.
calculator, correct?
Do you have the absolute value?
Yeah, how is that
Natalie.
right?
Did you put, oh, then what?
No, I'm confusing.
Okay, did you guys get 2.5?
Yeah.
Okay, so you can check it that way. Woo.
Should we just say, "Ooh"?
Okay, find the area of the region bounded by the graph y equals 2x squared plus 3x plus 2. The x-axis and the vertical line x equals 0 and x equal 2. What is the other name for the vertical line x equals 0?
The y-axis.
The y-axis. Thank you very much. Okay, so we probably should graph it. I will always be looking for your nice, pretty pictures.
My pictures were looking elite last night.
Were they?
Mine weren't.
Yeah, we didn't do it last night.
Okay, so if I'm from 0 to 2, the easiest way to do that would probably be plugging in 0 and 2. So if I plug 0 into that, I get 2. And if I plug 2 into that, I get 8 minus 6, 2 is 4. Right?
Yeah.
So somewhere up there. Well, it is a parabola, so it probably looks like this somewhere. Yeah? Do we know where?
It might be 2 minus 3.
We could find negative b over 2a, right? Negative b, so it'd be 3 over 4. So 3/4. Almost where I put it.
That is very close.
You're good.
So if you want to find the vertex, find the vertex. You know, but negative b over 3.
That's not important.
But it's not. You know that's what it looks like. So would you like to find the geometric shape for that?
No.
No, me neither.
because
That would be absolutely horrible. Because it wouldn't be a geometric shape, would it?
It'd be
You can make one rectangle and you just have curvy triangles.
We could do sector maybe. No. Anyway. So we need to find that area. So how are we going to find that area? Use the what?
Use the fundamental theorem of calculus.
Use the fundamental theorem of calculus. So the integral from what to what?
0 to 2.
0 to 2 of what?
Okay, well, I can only do so much.
I'm done talking.
What'd you say?
I'll never talk.
Of the equation, right? So 2x squared minus 3x plus 2 dx. So you find the antiderivative and I'll find the antiderivative. And we better be close.
Don't we just plug it in now?
No, you have to find the antiderivative first.
Which one is it? That's when you do the power thing?
My life is so fulfilled. I got 2/3 x cubed minus 3/2 x squared plus 2x.
Oh, you just leave it constant at the end?
Remember, you don't have to put the constant there. Okay, what's going to be nice about this one?
0.
It's 0. So since there is no,
You just have to do
you just have to do the first one. So we got 2 cubed is 8 times 2 is 16. Minus 4, actually 4 to be 2, 6. Did you guys get 6?
But yeah.
8, 2, 4, 6, yeah. Plus 4. So that'd be negative 2. So it'd be negative 6/3. So my answer is 10/3. The book does this. It's so awesome. 0 plus 0 plus 0.
They didn't write 2/3, 0 cubed minus 3 over 2.
No, they did not.
Plus 2 times.
But they did write minus 0 plus 0 plus 0 plus 0. I think that's kind of silly.
I've been saying silly too much these last like 2 days. I just keep catching myself saying silly.
I do not think I make you do the mean and the average value yet. I do think that's where I draw the line.
Glad you finally.
Yes, I finally did draw the
I
line.
understood boundaries.
Okay, so we are only finding the area under the curve today.